I'm going to introduce you Saverio Mucci with the talk What We Understood About Microservices.
Thank you everyone to be here. I'm really glad it's quite full, the room. I wasn't expecting. The talk is simply a first introduction to microservices. It's not a deep dive into the theme, but it's just to have an idea for exactly what we understood. That is, it was quite an hard migration for us, at least. Who am I? I am the CTO of install.com that we started a couple of years ago, 2 years. And I'm a Python developer since 2007 and started working with Django since 2009. So it's a while that I work inside, and I'm not an expert, of course. Our current platform, just to have an idea about the numbers and how much it is expanded, is processing for the moment 30 million events per day. Most of the application is Python Django, and we're using Tornado for the stressed part. I mean, Django is great, but it doesn't really scale, at least for us. And we are a relatively small team, so every huge change, as it could be a migration from a monolith to a microservice, is going to take a while for us. What is Install? Install is a platform for mobile advertising. We do supply our publisher and advertiser with tool for monetization or tools to have their application installed on the user's device. The platform itself is composed by a self-service platform that is completely written in Django, an ad server that is partially Django and partially Tornado, an application tracking system, and an in-app analytics that are our SDK, of course, written in Java and Objective-C, and a public API for our publishers. What was the problem in the beginning? We have this source that started, this project that started a couple of years ago that is getting quite big. So the current features are getting too many to be handled, and every new feature is going to take a while to be integrated inside the monolith, and probably is going to break something. And we couldn't really keep adding code to the repository that is getting really big. So we started looking for microservices. The current situation is something like this. We have this huge bunch of code that is our platform. That is, the code is shared between Tornado and Django. So it's already a forced status at this point. We do have 58,000 lines of code. That is not huge, but is enough to be scared of. And the test suite, it takes 29 minutes to run. So it means every time you make a change, you commit, you make a pull request, and you have to wait 29 minutes before knowing if it's running correctly. Of course, merging this pull request is going to take a while. You have to wait every time the 29 minutes. And it's a long amount of time if you think about it. If you want to have an agile development process, it's going to slow you down really hard. Of course, there are the 5 minutes for bootstrapping a new server and having an auto-scale system. This is quite an important number because you have 5 minutes to wait until your infrastructure can handle the new amount of requests that is coming. Let's say, just to keep it simple, it's not an advertising application, it's a bookshop. So we more or less know everyone what we are talking about. So we do have our bookshop. Our bookshop is composed by a few components, few features, let's say. The book catalog, the authentication, the cart, the wish list. And this is composed by always the same 50,000 lines of code. What happened? You have to add a new feature, let's say suggest a book. It is quite a small feature, okay? But you have to add it to the monolith. So you have to add it to the running code. You break something and always the same problems. You have to add other 15,000 lines of code, probably, I don't know, it was approximately an estimate. It's going to take 10 minutes more to run tests, so 39 minutes, okay? Even longer pull request. And the bootstrap of the machines is going to take, I don't know, 3 minutes more. So your risk to go down at a certain point. If you have a spike of traffic, it's going to be an issue. We found ourselves in the famous hole. And at a certain point, you really have to stop digging. Otherwise, you're going to have a problem. Not now, maybe, in a year from now, but it's going to be bigger, and maybe you're not even able to get out of it. So why we did see the point of the migration? Of course, the fear of change, that is, I would say, the first point. New developers, you start a new feature, and you're scared to break something. And if you're scared to break something, you slow down, of course. It was starting to slow down the development from a computational point of view of the computer where we are running development. So the Django server takes a while to restart. The EDA is getting slow during the search and during the autocomplete. Basically, the Git clone is going slower because you have to pull down a huge amount of information when you clone the repository. And the updates of the library is going to get harder and harder because you have Django 1.5 and now we are Django 1.9. You have to migrate 50,000 lines of code from the 1.5 to 1.9. Okay, wrong from our point of view to be at this point doing this, but at a certain point you have to deal with it. So we hypothesized the first ideal bookshop for us that was splitting up every single service. Right? So we have the book catalog, we do have the authentication service, we do have the cart service, the wish list, and our new feature with the suggestion. We put in front an API gateway to make sure that everything sticks together, and in front we keep our Django or Angular application. And this would be ideal. But as we said, we are a team of 7 people. It's hard to do all this work in 7 people in a short period of time. So it's going to take ages. The question is, we have a business running, the market is going on, and we can't really stop for just doing our refactoring. That is going to be important for us, but not from a commercial and economic point of view. What we really didn't want was to rewrite everything. Of course, no one wants that. To spend much time on this new feature, because as we said before, we just wanted to add a simple new feature. A single one. That is important from the market point of view. It might be change our business, but we need it fast. So 1 month the deadline we had. And we didn't want to break everything it was working, because every time you make an invoice, you want to be sure that the invoice is correct. We do have a test suite, as you know, 29 minutes, but you can trust it till a certain point. It's not 100%. You can have 100% code coverage, but not fixing every single problem. What happened? What we can really afford at this point, it was just to say, okay, we leave it everything as it is, so the monolith stays, and we're going to build a new service as a microservice. So we don't really change everything, but we just start decoupling what we can from what we have. So we thought really well, and we said, okay, what we're going to need for doing this? The basic stuff, not much more, just for an introduction to microservices, because you never build one, and it's the first time for you. You really have to learn everything from it. So we are going to start with 3 basic stuff. So the authentication, an API gateway, and an internal API to communicate between the services. So starting, authentication is quite simple to say. It's not extremely simple when you deal with it. We made a choice. We went for the JWT. That is, I would say, a nice solution, because you have a signed, encrypted, small and expirable token. that is going to work for humans. I mean, with human, the UX, so Angular, whatever you're using in your front end, is going to work with machines. So you can use the same token to authenticate the user through the API and make sure that the user making the request in the front end is going to be the same user that is going to make the request to the other services. And we didn't really want to have the necessity to verify remotely if the session was valid or not. Because if you have a session, you have a storage. You have a storage, it must be shared between services, and every service has to read from that storage in the same way. So the usual authentication works like this. Now you get the Angular application, whatever you have in front end, you supply username and password, and you get the cookie. Considering we didn't want to break everything, so it means detach the authentication service, we just added an authentication API on the current service, on current monolith, actually. What happens? This authentication is just going to verify if the session cookie is correct for that user and supply a JWT for that session or user. This means this doesn't really change anything you already have. You keep having your user in Django, you keep having your session in your database or Redis or wherever you keep them, and you have a new authentication service on top of it. What's the advantage is that this JWT, instead of the session, can be used even for API. So you just supply your authentication header with the JWT inside. And you can simply query the new suggestion service that is going to use the same JWT to access the other, not services, because are still in the monolith, but they're going to be detached after. At this point, you have quite a decent part of the infrastructure you're going to need. What happened? The client now has Angular in this case, is going to need every single address of each service. This is going to be an issue because you have to remember where you put it, and it's harder to version. It's going to be a mess in a long time. So, as we said before, we needed something to centralize this part. So we choose to add the API gateway pattern inside of it. Thanks. Prova. There it is. Sorry. So we're adding the API gateway. What is an API gateway? It's just a simple, let's say, in the beginning, you can see it as a proxy to use in front of all your API that are going to be exposed to the outside. So instead of having Angular querying directly the suggestion service, now we're starting to pass through the API gateway to make the same request. What happens for this? What's the advantages of having the API gateway in the middle? Is that it simplifies the development of your front-end application. It unifies the entry point of your API. It can supply even a first level of authentication or ACL. And there are a few features that are important for the future, not for the moment, because our service, as we said, is pretty simple. Now it's just a book, so it's pretty simple. But for the future, when you're going to have lots of resources, let's say I do want to suggest 10 books, this API gateway is going to be able to compose multiple results and return a single response. So, I mean, if you have a forward, backward, timeout on mobile devices and this kind of stuff, this is going to help you because it's going to be able to aggregate all the data and just send one response to the client. Of course, it's going to create a facade in front of all your services. So this is going to be easier for the future to split all the services. I mean, for the moment we have one single service, after it's going to be 3, 4, 5, 10, I don't know. Or maybe the single service is going to split up in 2. But you don't really want this to be visible to the outside world. Okay, till now it was simple. Here is where we really dropped. And it's really hard to figure out how to do it correctly, because correctly is it's just a word. In the end, it's correct is what you need. The internal communication between the services. Because you're not going to use, or maybe you want not to use the API gateway, but you just want your services to communicate between them. So, supposing that we have the API gateway there, and all the requests are passing through it, we do have the requests coming to the suggestion service that is going to get the list of user books to suppose what you want to suggest. Of course, you have to need what the user wished before. That is a simple information. And then you can get the detail of the book from the book catalog API. And here the question. What happens if I suggest a book that is not anymore present in the catalog? I get a 404 from the API. This is introducing a huge problem we still have to understand deeply, actually. And that is the eventual consistency. That, for me, is the main doubt I have about microservices for the moment. So we go for a trade-off of features. You get a smaller code base, the tests are running faster because they're less, of course. They scale independently, so if our suggestion service is stressed, it can be scaled independently from the rest of the application. You get multiple technologies, if you want or need, and you can consider to rewrite a single piece of it because it's small. You're not going to write 58,000 lines of code, of course, you're just going to write 10,000 maybe. The cost is really hard, actually, for me at least. This eventual consistency is going to be hard to handle. The integration tests are extremely more complex. Of course, you can't test anymore as it was before. Function, call, okay, unit test, simple, easy. You get an answer. The developed environment is going to be really, really difficult to handle because you have multiple services that are going to use multiple databases or other services to run, and you have to spawn them all together on your server, on your personal machine where you are developing. So it means 10 checkout of repositories, 5 databases, 3 Redis. I don't know, it's really hard. It's going to take a while to get in. This was the first time I saw a point in Docker, actually. You need something asynchronous because all these API requests going forward and backward it can't be done synchronously, of course. You don't want to stop the worker of Django, just make an API request remotely. And of course, asynchronous is harder than synchronous, so it's going to cost you from the development point of view. There are a few patterns, and we're going to see, I think, 2 or 3 of them. A couple of them, sorry. The basic one, it jumps in your mind to make these services communicate between them. It's a synchronous HTTP request. That was the previous example. Now you get the suggestion and you want the detail of the book. So forward, backward. Of course, this is easy to understand. It does just supply with this request reply pattern, but it just supplies you with request and reply. So it's going to be, you're not going to know if something has been deleted because you have to query the service to know if it's still there. And the server must be available. I mean, if everything's going to work and one of my services is going down, I can't know anymore the information that that service was supplying to me. And has single point of truth, of course, I need it to respond to the user. The other system is with an async MQP queue. So we are going to decouple the client and the server. So you're going to have something that is supplying the user with the information and something that is processing the changes. The broker buffers the messages. So if one of the server is going down, you are not going to have a problem about it, because the broker is going to keep the message until it's not processed. It supplies a variety of communication patterns. But you need something that is going to process the message. It can be you need one worker and one application that is serving the data. And this was where I got lost. So I really don't get it. I'm sorry, for me this was something I really still have to understand. I'm glad if any one of you can help us, because it's getting really hard. So how do I get the data? Because now they aren't together anymore. This is the main question that we have to answer. Because it was before like this. So we have the user table, we have the wish book, and the books. There is an hard constraint on the database that says that the user exists if there is a wish book and the book exists. Okay, this is easy. This is what we think every day. This is extremely easy for our mind to process and to understand. What happens if this constraint doesn't exist anymore, and you have the user and the wish book and the books that are connected to different databases? No one of them is sure that the other one exists. And you simply you're not anymore in control of your data, mainly. What happens? The wishlist service is going to need the book service. But the book service, he won't know what there is inside the book service. This is the problem of the reads. Of course, for the writes is even more difficult, because you're going to need a transaction that is going to update multiple services. So to phase commit, even harder. So pooling data, it's easy, but it might not exist. This is, of course, simpler. And you have the fresh data coming from your service. The drawbacks, of course, is the response time and the use availability done by this. Because we said, every time I need the book, I have to ask the book service to give it to me. And the book service, we don't know if it's up. So we thought, okay, we're going to replicate data. So we keep a cache somewhere in our place. So our wish book doesn't need anymore the books to run. Or at least it's going to need it sometimes. I don't know, it's going to be a cache. This is something we still have to figure out. The benefit of this part is that you don't need anymore the book service to be up. It does improve the latency. But of course, you have to keep them in sync. You have to keep them in sync because the list of books is present on the book service, and you have another service that have a list that is probably outdated. How do you keep them in sync? With an event-driven architecture. Event-driven architecture means you need a broker, you have to schedule an event, and so your wished book can update the book list that is available in this moment. So, in conclusion, what we saw. Sorry. When you see around, it was a study phase, so we went around and we saw all this beautiful stuff and say, okay, simple, you just decouple everything. And you take every service and you split up everything. And you don't think about what is going to mean this. So this is a lie. It's not that simple. You really have to think hard when you're doing this. What are the conclusions? I'm sorry for the current development of my application, actually, because it could have been much better if we would have started with a microservice in mind. Of course, a small project doesn't need a microservice infrastructure because it's going to cost you really, really lots of time. But all the projects are small in the beginning. So you have to think what's going to end up, what is going to mean in the time being. The migration is extremely hard. So I would suggest you to, if you still have to start, to think about the lifetime of your product and think if it's worth it to start with a microservice. And you really have to, you quite have to change the way of thinking because you don't have anymore the relational database, the data are spread, and there are a huge amount of problems that you usually don't deal with. But I would say that is a great migration because since we deployed the first version, it was extremely faster to develop new features. Because we had this small part of architecture that is going to allow us to spawn a new simple service to do something. It's extremely easy to create new features. Every deploy on the new feature is not going to break the rest of the code. So that's simply wonderful. Yeah, I'm just testing a new feature there, and I can deploy it 10 times per day, and I can screw up. Maybe something is in alpha, I don't care. And you are sure that you're not going to break all the rest. And the code review, for us, it was extremely easier, because you don't have to deal and thinking about 50,000 of lines of code before merging a new request. You just have to look to that context, to that specific feature. And yeah, I'm actually done. I'm sorry, I'm a bit short maybe. I hope it was fine. And thanks.
I would like to understand why you conflate microservices with splitting the database. I've done many microservices applications, and most of them, all the various services that needed data, shared another service which owned the database, either relational or non-relational, and that was a completely orthogonal decision to splitting the services. You seem to conflate them, and that seems to have been part of the difficulty, right? They split databases. Yeah. So I would like to understand that better. Thank you.
It was an art thought, actually. The thought, yeah, maybe we could introduce a service that was just handling the database. We thought about it. But we thought also that it might be more efficient for the future time to have it split it up, just simply because we do have the freedom. Every service in the end is going to have the freedom to have its own data structure and use it as it wants, not sharing the database. Of course, putting an API level on top, it would have been nice. I totally agree. But there would have been a migration moment between these two steps that the current application couldn't handle because it is in Django, synchronous, and is accessing the database directly. And the rest of the services, of course, are asynchronous and could access the API, but they would end up in the same place. The first thought.
Any other questions?
Okay, you say that you remove the concern of the client knowing which services are available by hiding them behind an API gateway. But how do you manage the API gateway knowing which services are available, which instances of the service are available when you scale them?
Yeah, that is the discovery point of view. There are a few projects, if you know Hystrix from Netflix, I think, strongly, that is actually doing this. It's another moving component that is going to be part of your application if you want it. We do not have a registration service, so I mean We just have a load balancer in front of all the instances of the service. So you just query the load balancer, the API gateway is going through the load balancer to the service and back. Simple.
Hi. Did you think about some sort of circuit breaking system for the connection between microservices?
Yeah, we thought about it. It's another step, as I told you. It's a process that is really going to take time. If you do have limited resources, it's not for free. It's totally not for free. Again, Astrix is doing that. It's monitoring the service and tell you if the service is up and down, and then you can remove the load balancer because you are going to use a client load balancer from that point of view. The fact of being asynchronous, it does that for you because you can introduce timeouts. So for the moment, we are breaking the circuit, just introducing timeouts on the remote request. Let's say.
Okay.
That's that.
Anyone? Still have some minutes left. Last chance. Okay. Thank you, Saverio.